Okay, now we're gonna find the following limit. So 1 over x to the fourth power times the integral of sine of t dt between 0 and x. Okay, and this function is defined if x is bigger than 0. Okay, so that's the key that we need to have that. Otherwise, we can't talk about that function. So therefore, we have this function defined for the positive values, real positive values. The next thing that we're gonna do is, since we are doing this evaluation, we can just go ahead and start working. So the limit here as x goes to 0 plus is in infinity times this one, which is 0. So we have a form that we can't conclude about. Okay, but we're gonna transform this limit in such a way that it will be nice to work with. Okay, so we can see here that if we call this one f or g and this is f, we can write it in this manner. So the let me do it here. So we can write it in the limit as x goes to 0 plus of the integral sine t dt between 0 and x over x to the power 4. Nothing has changed. Okay. So now what we can do is we can go ahead and evaluate again. When we do the evaluation, we're gonna get the limit as x goes to 0. We're gonna get 0 over 0. But this is great. Okay, it means that the limit might exist. We don't know if it exists, but we have this form here. This form would let us apply the L'Hospital's rule. Okay, and therefore the derivative of this one, the function is continuous. The derivative of this one, according to the fundamental theorem of calculus. So the derivative of this one here is just cosine of x. Okay. So you remember that if you have some function, let's say g of x defined by 0x of f of t dt, then g prime of x is just f of x. So this is the fundamental theorem of calculus, and we are using it here. Okay, therefore, so we're gonna apply the L'Hospital's rule. Okay, so now we have the limit as x goes to 0 plus of 0 between 0 and x of sine t dt over x to the power 4 is gonna equal the limit of the derivative of the top one over the bottom one. So it's gonna be the limit of the sine of x over 4x to the power 3. Okay, the derivative of the top over the one in the bottom. Now we check again. When we plug 0, we still have 0 over 0. That means we apply the L'Hospital's rule again. We still have the conditions, okay? So this is the limit as x goes to 0 plus sine x over 4x cubed. Now we're gonna see the limit of the derivatives. So the sine is gonna be the cosine and 12x squared for this function here. Now we evaluate again. So we're gonna have 1 over infinity, 1 over 0, sorry. So it's gonna be 1 over 0 and 0 from the right. What does it mean here now? So cosine of 0 is 1 and over 1 from the right. So that means over 0 from the right. That means this is infinity. And this proves that our limit, okay, the limit as x goes to 0 plus of 1 over x to the power 4, the integral of sine of t dt between 0 and x is infinite. So this is the value. Okay, and this ends our video. Thank you.